Okay, so we were on example 2 on the velocity. Let's see, dynamite was propelled from rock straight up. We had a nice little graph, and when we wanted to find part B, how high does the rock go? That was the vertex. Part A, when does the rock hit the ground? We found 0 and 10. Okay, we also found, okay, actually that's where we ended. C, the velocity of the rock at 256 feet. What function is the velocity function? F prime. So we found F prime, or S prime. In this case, it's an S function. So there's our velocity function. So if we want to know the velocity of the rock, write this down really quick, at 256 feet, what do we do? Where? Because is 256 time? No. So plug in 256, see what you get. There's only one t there, so it should be quite simple to solve. Wait. Oh. This is velocity. 256 feet is the position of the rock, or the dynamite, whatever is being propelled. The dynamite propels a rock. So 256, we're actually going to want to plug, we need to find at what point in the position function does it equal 256. 256 equals, the position function was, where is it? 160t minus 16t squared. Okay, and we'll use the velocity in a minute. This is a quadratic, right? So you can expect how many answers out of this? 2. And how do we set it up for the quadratic? Get 0 on one side. Usually we like this guy to be positive, so I'm going to choose to move everything to the left. So I have 16t squared minus 160t, because I'm subtracting that over to the left, plus 256 equals 0. Okay? Algebra 2 skills right there, 10th grade. Some of you are 9th grade. Some of you are juniors. That's 9th grade skills. Can you find the 2 points at which, because it's a quadratic with symmetry, there's going to be 2 points, right? That the rock will go up, eventually hit 256, go a little higher, and come back down and hit 256 again. So it's going to hit 256 twice. Do you remember quadratic formula? Or you can do factoring. Those are your 2 options. Once you've factored, use the 0 property to solve for your 2 times at which your rock will be 256. Okay, and what do those represent? What's the unit? Good. Yep, exactly. And once you get those numbers, make sure you know what those represent. You want to make your life easier? See if that guy's divisible by 16.
I did that.
You did? It is? Yeah, so factor out of 16. You factor out of 16, then I get t squared minus 10 plus, is this 16? And it's really nice. We have a 16, which division by, if I divide 16 on both sides, because of the 0, 16 is gone. So my two factors equaling 0 will be, let's see, two numbers that multiply to 16 but add to negative 10 will be negative 8 and negative 2, right? So the times at which the rock will hit, because it will hit once going up, and then it hits its maximum, which we found last time at 400, then it comes back down and hits again at 256, would be at time t equals 2 and 8. What's the unit? Seconds. Okay, now we can use the velocity formula. Now that we know the time, let's find the velocity at both of those times, right? And time is our t, so we can plug in t. That's what you do. So v of 2 and v of 8. Is Ariel a GTI, bro? Usually sits over here. I don't know. Okay, velocity at time 2. What'd you get, Gisu? Ooh, good job. Velocity would be feet per second, right? Good job. And the time 8, velocity at time 8? Okay, so what does this negative mean? It's going down. This is downward. So, if we were to write our answer in a complete sentence, right, we say the velocity of the rock at t equals 2 is 96 feet per second. And when t equals 8, the velocity is negative 96 feet per second because it's traveling downward. Traveling downward. That does not look like a D. Okay, any questions about that? Find the rock's acceleration at any given time. Okay, remember position was, where was our position? S of t is at the top of your paper, but I can't see both. 160 minus 16t squared. Velocity, which we already found, was negative 32t plus 160. So what's the acceleration at any given time? Velocity is s prime, right? So how do we find acceleration for any given time? S double prime, yep. So we'll take the derivative of the velocity, which is the second derivative of the position function. So at any given time, the acceleration is what? And what does that mean? Negative 32 what? Ooh, feet per second squared, because it's with time again, right? The velocity was feet per second, and you take the derivative of it, it's now per second again. So per second squared. Okay? Awesome. Flip it over. New problem. A ball is rolling along the x-axis. Okay, you have to take what they tell you in the problem and start visualizing what's going on. If a ball is rolling along the x-axis, how is it rolling? Horizontally, which means something about, what do we know about horizontal movements? Good, the slope would be 0 of the tangent line, right? So, we do have this function that is its position according to time as it's moving horizontally. If we graph that, you guys have calculators? S of t, let's take a look at its position to time. Hey, did you just finish your test too? Okay, yeah. No, my kids only got like 5-minute lunch too, so my pizza's still waiting to be eaten. We're just continuing on, and I'm recording this too, so the first part you missed, you can just go to my website and watch it. We're on number 3 on the notes from last time. Okay. Essentially, if you look at the graph, here's 2, here is 4. The graph does something like this, right? Is that right? Who's graphed it? Check your modes. See if that changes it. That's interesting. No, you should have parentheses around the fraction. Oh, cubed. That's it. That x squared should be cubed. Okay. How does everyone else's turn out? Like that? Okay. So, let's talk about what's going on with the movement of the ball. When it's increasing, which direction is the ball going? Which direction is it moving if it's increasing? Remember, this is the position. Now, if we're going horizontally, what are our 2 options? Okay, you have forwards and backwards. Could we say left and right is forwards and backwards? So if this is increasing, you're going forward. So from here to here, we're going forward. And what happens from here to here? It's backwards. Yep, we're going backward. And then for the rest of the time, it's going forward. Okay, because we're just going horizontally, so we're going back and forth. That's really all we can do. So, when does the ball change direction? Well, now this is just a rough graph that I hand did, but we can find it. When does the ball change direction? What would we be looking for? The zeros of the tangent line, so that would be when velocity is 0. So tell me when I get to a 0. Oh, so like maybe a maximum and a minimum. Okay, so we'll have those when, let's do that right here, s prime of t, or the velocity, equals 0, because we're looking for a tangent line of 0. That's when it's changing from going forwards to backwards. So when does this happen? Well, my sketch is pretty rough, so don't just go off of my sketch. Oh, what am I doing? You guys should do that. What's the velocity? What would the velocity function be? That's the position. What do we do to find the velocity? Take the derivative. Okay, John, can you tell me what that derivative would be for a velocity function?
So that would be t squared minus 6t plus 8.
Great. And then the minus t goes to 0, right? It vanishes when we take the derivative of it because it's t to the 0 power. Okay, so if we want to know when it changes direction, we want to know when velocity equals 0. So what would you do? You're going to do what? Set it equal to 0, and then we have a nice little quadratic, which you guys can factor and find the zeros, solutions, and these would be the x-intercepts on the velocity graph. So where the velocity graph crosses the x-axis, those are your, would be the tangent line of 0, the maxes and mins. Yeah. But my second one I didn't draw very well, right? What'd you get? Time t equals what? 4 seconds and 2 seconds, because your factors would be t minus 4 and t minus 2. So t equals 2 and 4 seconds. Okay, so in a full sentence we could say the ball changes direction, not position, direction at t equals 2 and 4 seconds. If I said because, what would you add? Because the, how do you know this? Okay, and the tangent line is which, comes from which function? The slope of that tangent line comes from which function? What did we set equal to 0? Because v of t equals 0. And changes signs there. Okay. Make sure when you're doing your homework, you're not just getting a number, you're actually understanding what does that number mean. When is the ball moving right? When is the ball moving right? I think we can answer this pretty quickly, right? Because we've already done it. Ah. Okay, so it's moving right from which intervals? The ball is moving right from 0 to 2. Now at 2 it changes direction. So right at 2, is it moving right or left? Can we tell? No, so we put a parenthesis. But at the beginning there's only one direction going. So I'm going to put a bracket. And then we can put union or and. Where else? Ooh, because of the arrow. Are we going to ever reach infinity? No, so we do a parenthesis. That's seconds, and this is because what Kyle said, the velocity is positive, right? Because the position function is increasing, so the velocity would be positive. So we could say v of t is greater than 0. Okay, fill out the next one. When is the ball moving left? And be very specific, right? The same way we did for moving right. Hey, Margarita, what'd you get? 4, it's moving right, so it'd have to be 2 to 4. Do they get brackets or parentheses? Well, at 2, it's changing directions. So, and same at 4, it's changing from moving right to left or left to right, so those would be parentheses. Seconds, because the velocity, if we're moving to the left or moving backwards, our velocity would be negative, less than 0. Okay, now I'm going to scratch out up and put ing, speeding, and down, change it to ing, slowing. Because, like we did last time, if I throw my marker, it's actually slowing as it goes up, even though we say slow down. And it's actually speeding when I drop it because of gravity when it's moving down. So that's confusing. So we're just going to say speeding and slowing. When is the ball accelerating? When is it speeding versus slowing down? When what's coming down?
Above the x-axis.
Okay, when what is above the x-axis? Which function? We have 3 functions. Which function should we be looking at? When the velocity is over. So we could draw a nice little sketch of the velocity, right? The original was cubic. So the velocity function is decreasing by 1 power. The velocity function would be quadratic, a parabola. And we know it crosses at what? 2 and 4? And we already said on the way to 2, from 0 to 2, it's positive. And then from 2 to 4, we said it was negative, and then it becomes positive again. Okay, so when is, let's put little signs in here. Here, velocity is positive, and here we have velocity negative, right? Velocity negative. Let's put in acceleration. What's the acceleration sign for this stretch? Negative. Why? It's decreasing. Down here, also negative because it's still decreasing. Turn around, and the next 2 stretches would be acceleration is increasing, positive. So when is it speeding? If you look on your front page, remember on the very bottom of the front page, speeding happens when velocity and acceleration have the same sign. So we're looking for speeding, same sign. From, 2 to 3, because nice little symmetry on our quadratics. 2 to 3 and 4 to infinity, because then they both be positive. So parenthesis 2 to 3, union 4 to infinity. And we can write in front of that. The ball is accelerating on the interval 2 to 3 and 4 to infinity seconds. Actually, and you can write because here v of t and a of t have the same sign. So for speeding, 2 e's. I need a way to remember this. Speeding, 2 e's. I don't know. They both have the same sign. Speeding, 2 e's. They have the same sign. They match. Velocity and acceleration when we're speeding have the same sign. Versus slowing down, they have same sign or different signs? Different. Because if it's speeding here and here, then the other 2 sections, it has to be slowing because they have different signs. So the ball is, oh, we should probably say speeding, not accelerating, is slowing on the interval, what to what? Where does it start slowing? Can there be negative time? Is the ball going to be a negative time? No. So I'm going to do bracket 0 to 2. And where else? 3 to 4 with parentheses. Seconds. Because velocity and acceleration have different signs. Okay, part D says displacement. Go back to the first page. What's displacement? Vocabulary. Change of position. It's the ending position, subtract the starting position. We get out, what did I say, 55? Is that right? So, okay, we have a couple minutes here. So, finding the ball's displacement for the first 3 seconds. It's just the change of position, the end time, its location at the end time minus its location at the start time. And for us, it says for the first 3 seconds. So the end time would be at what time? 3, and the start time would be at 0. Can you find that? S of 3 minus S of 0. This is position, so we should be using the position function. Good. Good. Especially like the way Reed's doing it. He put a big old bracket, and he started plugging in the 3. 1/3, 3 cubed minus 3 squared plus 8, 3 minus 10. That's the first evaluating at 3, right? When position is 3. Well, time is 3. Minus, big old bracket, do it again, but put the 0 in. And 0 is such a nice number to work with, except for when dividing. Yeah. Gone, 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 right? So this minus 10, and we're subtracting the minus 10, so it'll end up being a positive 10, and then this is gone, gone. So you just have to calculate that out. So our change of position ends up being what? Okay, what are you getting? Good. I appreciate so much the units, not just 6, it's 6 feet. So we would say the ball's displacement for the first 3 seconds is 6 feet. Is that what you do in physics a lot? Seconds is 6 feet. Okay. Average velocity, we can at least set it up. Average velocity, ooh. What do we use? Average velocity. Average velocity. For the first 3 seconds, what does average velocity mean? There's other phrases that mean the same thing as average velocity. Yeah. Rate of change. I'm just doing the slope formula. For the first 3 seconds, so s of 3 minus s of 0, which you already found was 6, right? Divided by 3 minus 0, which is 3. So our rate of change is what? Our average velocity is?
So that's position. So that's still when we use the velocity.
The average, but, for the first 3 seconds?
I don't know, I'm asking you the question. Because really for average velocity, what do we want to know the velocity at 3?
Average velocity is change of position over change of time. Yeah, first page. Change of position over change of time. But good questions, makes me think a lot. Okay, so this is 2, what? For average velocity, what do we put? Feet. Get out that meters thing. Feet per second. Okay? Start working on the section for this. I know this was super short because it's a short day. You all have that whatsy, right?
Yeah.
Please explain what the problem is telling you piece by piece. Explain why the answer you're choosing is correct and why the other ones aren't correct. Because you can pick it apart and know exactly which one it is by reasoning it out. You can do it. There's only one correct answer. It comes straight from a AP Calculus exam, so there's only one correct answer. What? Yeah, just one, A, B, C, D, or E. I think there are 5 options. Just choose one of them.